Okay, so this is where we um, stopped in class. Technically, this is where we stopped in class. So hopefully you sort of remember a little bit about our conversation on morbidity and mortality and the expansion of morbidity, which is what's actually happening versus the compression of morbidity, which is what we would like to have happen. So we're going to go over some additional aging content starting with physical activity. So this is showing us the percentage. Sorry, let me get a laser pointer so you can follow along with what I'm talking about. Okay, so we're talking about the percentage of people 65 years of age and older. So we're looking at the young old here, all the way up to the oldest old, participating in leisure time aerobic and muscle strengthening activities that meet the 2008 physical activity guidelines by age group. Okay, and this was reported. So this is self-report data. And mostly I just want to point out, look at where sort of the threshold is. So 65 to 74 is that highest line here. And we've increased for one, which is great. But also the total number, even if we're generous, right, we're about right in the middle there, is 15% of adults 65 to 74 years old are meeting physical activity guidelines. So really low proportion of individuals. And then the older that we get, so down here at the 85 and over, right, we're really low, well below 10%. If we're generous, maybe we're at 5% of that population is meeting guidelines. Now, some of you might be like, well, can people who are 85 and over meet the guidelines? Well, one, this 5% of the population that's at least reporting that they're capable of it. But I'll present some evidence later that sort of talks about older individuals' abilities. So just presenting data on obesity, there's really limited evidence, in my opinion, that suggests that these two necessarily go hand in hand, the lack of physical activity and then obesity. But we do see relatively high prevalence of obesity in older adults, right? So you see, again, if we're maxing out here, maybe around 40% prevalence in those 65 to 74. Notice, though, that it actually goes down for individuals 75 and over. So take like 30 seconds and think about, why is the prevalence of obesity going down as age goes up? So I haven't given you 30 seconds, but you're welcome to pause and continue thinking about this for a minute. It's sort of an interesting question. One of the potential reasons would be that obese individuals who are 65 to 74 years old may have increased disease incidence, and those diseases may result in mortality. These individuals may be dying. So it would make sense that the individuals left over, so 75 and over, are actually, generally speaking, a healthier population, therefore more maybe overweight or normal weight individuals. And notice not much of a difference in terms of trend nor prevalence between males and females. So this is looking at what activities are these adults engaging in, right? They're not engaging in activities that cause them to meet the guidelines. So what are they doing? So big percentage of the time is spent sleeping, as it should be, right? About 40% of their time. Whereas in like an average population, we might expect that to be closer to like 30%. Then leisure activities, but obviously those leisure activities are not physical activity, but it's their leisure time. Work, now this is sort of interesting. We see that change. So from 55 to 64, work is taking up about 17% of the day. Then from 65 to 74, 6%, and then 1% down at the 75 and over. So, right, individuals are retiring at this age. So we would expect to see them engaging in less uh, occupational time, less time in their occupation. Household activities, so pretty consistent across 8, 10, 9%. Care for and helping others, pretty consistent again, but low amounts. Eating and drinking, similar. Purchasing goods and services, pretty low. Grooming, pretty low. And then other activities, And down here, we see that other activities includes things such as educational activities, organizational, civic, and religious activities, and then telephone calls. So for those of you who may be engaging in the volunteer opportunity, just a quick reminder on that, right? We talked about this at the end of class last week. That would be some of their phone call time, right? Would be interacting with you theoretically. So I hope some of you will at least consider that. I think it's a great opportunity. Okay, and then so this is looking at total time for activities in an average day. This is just looking at their leisure time usage. So in their leisure time, what are they doing? Pretty low amount of socializing, but huge amount of watching TV. And if we consider that in the context of the papers that we've read, not last week, but the week before, that paper on sedentary behavior, right? That's a pretty big problem that well over 50% of their leisure time is spent watching TV, considering that one, different types of sedentary behavior have different impact on health, with TV viewing and screen time generally speaking being associated with decreased or less than ideal health outcomes, and other sedentary behaviors like reading or playing games or writing would be more associated with positive health outcomes. So pretty big concern there, and an area for potential intervention. Participating in sport, exercise, and recreation. So again, pretty low amount there. Relaxing and thinking, also still pretty low. Maybe that's the meditation category. Maybe if we could substitute some of that in for some of this TV time, we'd be doing a little better. Then you see reading, right? And we actually see that take a little bit of a peak up at 75 and over. Again, that may be partly because some of the individuals who were not reading are actually dying because of the negative impact of some of the other sedentary behaviors they're engaging in. And maybe the individuals that are left in that 75 and over category are typically engaging in slightly healthier behaviors. And then other leisure activities. So again, just examples, playing games, using the computer, doing arts and crafts, right, are some examples of what those other activities might be. Okay, so we are going to focus on muscular health in the older population. So here we were just sort of looking at associations. What are they doing? They're not meeting the guidelines. One of the guidelines is resistance training. So I wanted to focus a little bit on sort of what's happening when they do resistance training or when they don't do resistance training. So we're looking here at strength and power. So how do we measure it first before we talk about it? So 1 repetition maximums are acceptable in older adults. They are often discouraged, and in specific populations with specific diseases, they would be discouraged. But I will present some data later that looks at why you would potentially do it, and that it is in fact safe to do a 1 repetition maximum on older adults. But you want to consider what equipment you have access to, and also we could consider estimating. So I could do maybe a 3 repetition maximum, and then there are pretty standardized charts that would allow you to then guess at someone's 1 repetition maximum based on their 3 repetition maximum. Okay, so that's what we see here is sort of deadlifting at a 1 repetition maximum. You can see the belt maybe for a little bit of additional support. But older adults are perfectly capable of lifting heavy weights and barbells and free weights, etc. Isometric hand grip dynamometer, that's what you see on this right-hand side. Some of you maybe have used something that looks really similar to this in the exercise physiology lab. We do have one of those in there. There are other ways there are other forms of dynamometry, but I know we have this specific model in the exercise physiology lab. If it wasn't pulled out during your lab, ask if you can see it, because I think it's kind of fun to just be able to see, oh, this is a picture I saw at lecture, and you actually can use that equipment. So pretty interesting. And there's some really interesting work looking at hand grip and associations with morbidity and mortality. Does that mean I should train hand grip? Not necessarily, but that if I have done other things like, say, deadlifting that would increase my hand grip strength or maintain my hand grip strength, right, then I might be a little bit healthier. Isokinetic dynamometry means that isokinetic means we're moving at the same speed throughout the range of motion. This is really expensive equipment. It's tough to get access to, so I typically don't recommend it, and we're not going to spend a lot of time talking about it. Wind gates down here are really fun, and you will do those in the exercise physiology lab as well. So you're on a bike and sorry, you bike as fast as you can for 30 seconds, essentially, with increasing resistance on the bike. There are modifications to the Wingate protocol. So you could do, instead of like the 30-second protocol, you could do a 15-second protocol. You can also adjust how much resistance is dropped on the bike. So at a certain point, usually you get people going up as fast as they can, and then you drop a weight that then increases resistance exponentially for that individual. You can change the amount of weight that you drop if you're working, let's say, with an older individual or maybe a frail individual. Couple other ways we can do it. Sit to stand reps 4 times. So sit to stand is literally just how long it takes me to go from here and then back down. Okay. Typically without use of the armrests. You can look at gait speed. So literally we'll measure out, let's say 100 feet, and we'll see how fast they can walk 100 feet. And then also the timed up and go, and that's usually 6 meters. So that's the time it takes for them to rise from the chair, walk, then return back and sit down again. Okay, so lots of fun different ways to measure this, but these are some of the things that you might see in the literature if you're looking at aging adults in particular. So when we engage in resistance training or don't engage in resistance training, we see changes in the muscle. So generally with aging, we're going to see changes in the muscle regardless, and we'll talk about some of those. But here is some particularly interesting data. So this is the thigh muscle of a 24-year-old male. This is the thigh muscle of a 66-year-old male. Okay, so you can see same individual here. And we see a lot more lipids in here. So this sort of white stuff, that is indicative of lipids. And then this darker matter is indicative of sort of the cross-sectional area of the muscle. And so how much of it we have, but also notice, right, lipids are sort of getting in here and infiltrating that muscle. So that can decrease the quality of what muscle is there. What's really cool, oh, we're going to skip through, ooh, wow, that is interesting. Okay, we're going to start here. Sorry. I did not realize what order I had the animations in. Okay, so first, we have muscle cross-sectional area here. Okay, so this would be like the largest cross-sectional area. You can see it gets a little smaller here. So as I increase in age, chances are my muscle cross-sectional area is going to go down. And we see that decrease start usually around 25 years of age in the average individual. Now, you lose about 1 to 2% per year after the age of 50. Okay, so looking at about 50 here, that increases dramatically once we hit 70. So now we're losing about 3% per year. So across a decade, right, that's a huge, huge shift. And that's a significant problem, especially if we're thinking about function, like how adults are functioning. And we're going to come to that in a couple of slides. Okay, this is really the most interesting thing for me, at least in this set of slides. So here we have a 24-year-old male. Here we've got a 66-year-old male. These are the cross-sectional areas of two different 66-year-old males. I want you to spend a second and think about, okay, these are two different males. What's the difference between these two males? Both 66 years old, both male biologically. What do we think the difference is? Okay, so I think this is really fun to sort of think about and to show the significant impact that physical activity can have on the quality of our muscle mass as we age. But this male, their average steps per day was 3,000, and the amount of time that they were spending in moderate intensity physical activity was 22 minutes a day. So anything greater than 3 METs. They were spending about 22 minutes a day in this male was. This male, on the other hand, their average steps are 12,445 per day, and they are spending 130 minutes or more per day in moderate to vigorous physical activity. So that's again, same operationalized the same way in 3 METs or greater. Okay. So huge difference here. So you can have an impact on how you age. And that's sort of what I want to get at here. And it's pretty striking, I think, when you compare these pictures side by side. Okay. So I'm going to pop up sort of a list of some of the changes that we see here in a moment, but I want you to take a look at these three figures. Now, they're obviously sort of the same figure. Notice red is innervating type 1 muscle fiber, and then this white is innervating type 2 muscle fibers. Okay, so this is a young, what we would assume is pretty healthy muscle. Notice how that's then changing as we age. Okay, so especially look at the type 2 muscle fibers. Okay, and then when we're looking, we're going into sarcopenia, right? Now, see how that, what changes are happening now as a result of that. And I'm going to give you a minute to look at this. Okay, so I hope you took some time to at least think through and look at some of these differences. But generally speaking, the really significant change that we see here is one, just look at the total size. Whoa. Oh, there's my laser pointer. Okay. Total size just changes, right? I have decreased cross-sectional area of the muscle, right? Which is what we looked at in the last slide. What I also see though is smaller type 2 muscle fibers. Okay. So a little bit of atrophy of my type 2 muscle fibers. They're still there, right? Maybe a little bit fewer, right? So we have 1, 2, 3, 4, 5, 6. Now we've got 1, 2, 3, 4. Okay. What's happened here is these ones that we have gotten smaller, but also I've lost this one. This is no longer innervated. Okay. So that's just I mean, it's a dying muscle cell essentially. And here what's happening is this was a type 2 muscle fiber that's now transitioned into a type 1. So we see reinnervation of type 2 muscle fibers with type 1 motor units. Okay, so a couple of pretty significant changes happening. So here is maybe. There we go. Okay. So we see reduced muscle mass, right? That's what we were talking about in the beginning. So fewer muscle fibers and then atrophy of the type 2. And we do see atrophy of type 1 muscle fibers, but type 1 is typically preserved much longer than type 2 is. Wow, I guess I'm going to have to click through this. I'm not sure why this isn't working anymore. Okay. We see reduced quality of the muscle, so more connective tissue, some of that fatty infiltration. So that was shown really well about in the last slide when we were looking at that muscle quality. We have fiber type changes, so we see decreased size and number of type 2 fibers, and then that denervation of the type 2 and reinnervation of type 1. So that's the denervation here, and then the reinnervation happening here. And then neuromuscular changes. So we see motor neuron loss, slower signal velocity. This is a really interesting thing. So demyelination of neurons happens. We don't have the time to go into that, but hopefully you have sort of covered that in some of your exercise physiology coursework. Essentially, how quickly my brain can communicate to my body to contract and relax muscles, that speed decreases. And then we also see that motor units decrease in number, but also increase in size. So what that would indicate, right? If in order to do fine motor movement, so right, I can sort of get every finger to individually contract, a little bit of overlap there. Okay. When my motor units increase in size but decrease in number, now I have fewer nerve endings coming that can communicate to this, say, pinky finger. So maybe now every time I move my pinky, it's always going to move maybe these 3 fingers or maybe even these 4 fingers. Okay, so because I have now a single motor unit that's now responsible for all 4, whereas I used to have 6 or 7, right, that were innervating everything. Okay, those are fake numbers, by the way. Okay, so I lose fine motor control as well. All right. This is way too much text for a slide, and I'm sorry. It will get better in the future. I would pause and maybe take some time to run through this on your own, but basically, I just wanted to show that there are a lot of different ways that we see sort of muscle progressing from young muscle to aging muscle to sarcopenia. Okay, and some of the things we might consider our lifestyle, so their physical activity and nutrition. Typically, older adults aren't eating enough, particularly not enough protein, and so we might see some of the decreased cross-sectional area as well as infiltration of fat into the muscle because of these 2 things, especially. Changes in endocrine hormones. We have talked a little bit about or IGF. Sorry, that's what we were talking about during cognitive function. So IGF has a little bit of an impact on angiogenesis in the brain, so increased capillaries there. It also has an effect on maintenance of muscle tissue. Okay. Lots of other hormones, right? Growth hormone, testosterone, changes in estrogen, insulin resistance, all of these things, insulin resistance, especially with quality of muscle, but the rest maybe mostly just with sort of muscle size, would have significant impacts. Inflammation and oxidative stress, I'm not going to go too deeply into that, but especially if we look at sort of sarcopenic obesity, we see fat infiltration of skeletal muscle, which is associated with reduced strength and functional status. So again, sort of a quality issue here. Additionally, we can sort of combat this inflammation and oxidative stress through physical activity and through nutrition. So if I get exogenous antioxidants through, let's say, berries, or juices, or dark leafy greens sometimes, I could combat some of this as well. And then genes and heritable influence. So there is an estimation that about 35 to 65% of decreases in strength and performance are a result of genetics. However, we don't really know what's happening there. And there's a big question of epigenetics, which is the idea that what we do, so our level of activity or sedentary time, our nutrition, our exposure to sunlight, etc., impacts what genes are expressed, and that's your epigenetic piece. So yes, it's genetic, but could there also be a lifestyle component to the genetic piece? Also, yes. Okay, so then the real question is like, are we addressing the quantity of muscle, or should we address the quality of muscle? And ultimately, any activity you do is going to address both, at least to some degree. And that's where one of the papers that you'll read this week, it talks about sort of the specificity of training and how I can train specifically for specific things. And in that paper, they're looking at power training. Yeah, I'm not going to get too deep into it. I'm going to let you read the paper, and if you have questions, we can address some of those in class on Thursday. Possible treatments, I'm not going to go over these because it's sort of what we've already talked about, lifestyle, so physical activity, nutrition, and then you can do hormone replacement therapy. So especially for peri and postmenopausal women, hormone replacement is pretty common. Testosterone supplementation can be common for older men as well. There are some significant health concerns with those things. We're not going to get too deep into them. But if you have questions, I'm happy to sort of chat about that a little bit more on Thursday as well. And then inflammation and antioxidants as well. Notice the ACE inhibitors, right? We came across that when we were talking about high blood pressure. So that can be used, those ACE inhibitors can be used for multiple things, and we may see those play a role in maintenance of lean tissue as well. Really briefly, before we get too deep, I just want to say, Kate, when we do treat loss of muscle tissue, we're effective. So we can improve 1 repetition leg press by engaging in, I believe this was 8 weeks of resistance training. So in men, we saw a 25% increase, in women, a 31% increase in leg press. So regardless of sex, we were seeing improvements in at least strength production. Okay, so the recommendations that ACSM gives for older adults in terms of resistance training is to be greater than or equal to 2 days a week, typically starting out with a lighter intensity and progressing to a heavier intensity. They recommend not doing a 1 repetition maximum. I'm going to present some data that I think uh, at least questions that idea. And they recommend using RPE. I highly recommend using RPE, sort of regardless of age, actually. But that's maybe the focus of that is maybe for a different class. And then sets and reps, 1 to 3 sets, 8 to 12 repetitions is what's recommended. However, for power training specifically, which the article you read this week focuses on, typically light to moderate intensity. So that's at 30 to 60% 1 repetition maximum range, 1 to 3 sets, 6 to 10 repetitions. So a little bit lower repetition range here as well. I just wanted to highlight that. However, there are some common things like why. So we have a really low proportion of older adults engaging in aerobic and resistance training. So why are they not doing this, right? We have the recommendations. They likely are aware of what they are. They're likely aware that they should be doing it. So why aren't they? So one thing can be equipment, right? There's lots of it. What do they choose from? How do they use it? It's complicated. Maybe they're not used to it. They don't know what to do in the gym. How do they know? Okay, if they do in fact go, how do we keep them going? How do we help them realize they are making progress? Where are they supposed to be feeling this? What are they supposed to be seeing in terms of differences? And just in general, it's sort of intimidating, and there's not a lot of accommodation for, let's say, someone who can't use a machine, who doesn't actually have the strength to start even at the lowest weight on a given machine. So they may need some additional help, which comes to sort of the people aspect. So one thing that can also be intimidating is you walk into a gym, let's say, and you see a lot of young people, and if you're an older adult, you sort of can feel out of place. Trainers and instructors can have a role in that. There is a big difference between, in my opinion, someone who's training and someone who's instructing and educating. If you help to educate clients and older adults, they can be more autonomous. They can do this on their own. We build up their confidence, their self-efficacy. A trainer, however, in my opinion, is much more often interested in creating sort of this dependence, right? Your income is dependent on people coming to you. And so you, as a trainer, may encourage their belief that they won't be successful without you, which is false. They can be successful without you. So, not that trainers can't be helpful, but the mentality is a little bit different if I'm training someone versus if I'm helping to instruct them, if I'm helping to educate them. One other issue with people can be, older adults looking at other individuals saying, okay, well, they're doing this, so I should do this. But if they are engaging in if they're doing poor form or not using a machine the way that it should be used, we could see increased injury risk. I personally think that's an overestimated concern. I would much rather have someone do something with poor form than not do it at all most of the time. There are a few exceptions to that rule, but I think we get over concerned about form and less concerned about, okay, are they actually feeling it? Are they doing this? Are they really going to hurt themselves with that poor form? Or does it just not look as pretty or specifically the way we want it to look? So I think we get a little too hung up on that. And then the last thing is noise, like environment in general. So lots of things that we could think about with older individuals, but we do see, again, generally decreases in cognitive function with aging. So noise makes processing things more difficult. The processing is typically a little bit slower, so that can be frustrating. It can be distracting. It can make it difficult to focus on their workout or to know what they should be doing. They can become disoriented. And that sort of paints a bit of a dire picture, I think, of older adults. Many older adults are not at the point where their cognitive function has declined, so that they're struggling with that. But in any case, it's something to be aware of. So noise, crowds, sweat or lack of cleanliness can be an issue, especially with susceptibility to disease, as we see decreased immune function in older adults. Vision can also obviously be an issue as we see that decline with age. Okay, so these are some, I'm going to try to fly through these last slides because I know this is long. Sorry. These are some results from this really cool study done in the 1990s. For the record, so this is one of your papers for this week. So you have two papers. This paper, I wanted to sort of just at least give you a chance to look at it because I think it's so cool. I don't care that you dig really deep into this paper. I'd rather have you focus a little bit more on the straight paper, which is the first paper that you'll come across in perusal. But in any case, this is a really cool study. So this was done on nonagenarians. So the average age of participants in this study was 90 years old, and the range was 86 to 96. So these are old individuals. There were only 10 individuals in the study, and only 8 ended up completing the study. Um, they were in a residential facility for about 3.5 years. Um, Most of them had experienced a fall, and 7 of the 10 were using assistive devices. So that's like a cane or a wheelchair or a walker. Um, the average number of chronic diseases per person was 4.5. So these are sick elderly individuals. Sick old adults is a more appropriate term, I suppose. And then daily meds per person was 4.4. So again, taking medication presumably to manage these chronic conditions. At baseline, men had higher fat-free mass than women, not super surprising based on some of the research we've looked at earlier, and 40% were undernourished, so really low BMIs. So the first question that this study was sort of asking is, can we do this in older adults? So this was heavy resistance training, including doing 1 repetition maximum testing. And these are older adults living in a full-time care facility. Okay, so understand that this is the population that this had, as far as I'm aware, this had never been done before. The general idea was that you cannot do this, in fact, in older adults. So they were checking to see, could we do a 1 repetition maximum in this population? They did 6-meter walk time as well as a chair rise time. So, and then they engaged in 8 weeks of training 3 times a week, 3 sets of 8 repetitions at 80% of their 1 repetition maximum. So notice that in the recommendations, in the ACSM recommendations, they don't even get to 80%. And these are newer recommendations than this study. This study had been produced long before these recommendations came out. So I still think that we're struggling to see older adults as capable of a lot, and that their bodies are still capable of adapting to exercise. So in any case, recommendations are 60 to 70%, but this study showed that, in fact, you could do 80% of their 1 repetition maximum. They then retested their 1 repetition maximum every 2 weeks. Okay, so they were very interested in progressing. So they didn't just say, this is your 80% 1 rep max, we're going to do this for 8 weeks. They said, this is your 80% 1 rep max now, but we expect that to change. So we're going to retest it in 2 weeks. And as you see, they then absolutely changed their 1 repetition maximum. And then they did 2 to 4 weeks of detraining in this study as well, and measured outcomes. So at baseline, what we saw was that with 1 repetition maximum, increases in 1 repetition maximum were associated with decreases in the 6-meter walk time, right? That's a good thing. We want individuals to be able to walk 6 meters more quickly, and that was associated with increases in strength. Notice the total amount of time here too. So that's what we're going to talk about in the next time. But the range for what it took individuals to walk 6 meters, so about 18 feet, right, was 7.4 all the way up to 48.3 seconds. Okay. And the 20-foot walk time, so a little bit different, but or approximately 20 feet. Okay, yeah. So we're looking the average time. So the range was 7.4 to 48, but the average was 22 seconds. So mostly I want you to think about that in terms of the practical use. And hopefully you should have probably come across this in aging and exercise if you've taken that class, but they do an assignment called crossing the intersection, or at least they used to, and how long it might take an individual to cross the intersection. Many intersections you're looking at, they have about 15 seconds. The average adult in this study could not have crossed the intersection in that amount of time. Okay, so we're decreasing their independence at the very least. What was pretty impressive, right? So they looked at left leg and right leg separately, but the average increase in leg extension strength after these 8 weeks, the average increase was 174%. Okay, with a range of 61 to 374% increase in 8 weeks. That is a wild amount of improvement in 8 weeks. Every time look at this study, I'm just blown away by how drastic that changes. Average right leg 167, average left leg 180% increase. So clearly, these adults are capable of change, of growth. Some pretty cool observations from the study. There was no plateau, meaning these individuals didn't hit 374%, and then we saw that sort of line cap off. No, no, no. It was still going up in a linear fashion. So they still had room for growth. There was also no sex-based difference. So men and women both adapted similarly. Um, with detraining, there was a 32. So after 4 weeks, they did lose 32% of what they'd gained. So it's it's trainable, but it's also detrainable. Okay, so we can gain or lose, but also, right, they lost 32% of what they had gained in 4 weeks. What if they started again after 4 weeks? Okay, well, they'd lost some, but now our starting point is different. Okay, so maybe some breaks, maybe they don't need to train 3 times a week, but maybe if they trained 2 times a week, right, we could maintain a much higher level. Yes, just stating that 1 repetition maximums and 80% 1 RM are safe and feasible in this population. They did not change gait speed. They did change, I didn't go over this, so tandem gait, but we saw improvements there. One of the big things that came out of this study was that 2 of the individuals who were using canes, so you saw that I think 8 of these individuals were using assisted walking devices. 2 of them no longer needed them after 8 weeks. After 2 months, if you go in and tell most people, hey, in 2 months I could get you to a point where you no longer need this cane, they would be like, okay, yeah, let's do this. So it had really practical value for these individuals. It wasn't just, oh, well, you increase strength. Does that mean anything? Yeah, it did for them. It meant they didn't need a cane anymore. And then 1 of 3 of them who could not rise from a chair without the arms then could. Okay. So again, just increasing their functional ability. Think about many times if you go to, let's say, a concert in the park, those chairs don't have armrests, and so can they be functional in society potentially? Okay, I'm not going to go over this much, but basically, if you engage in exercise, regardless of what that exercise is, this was aerobic exercise, we saw decreased hip risk fracture for women. So significant decrease, right? This would indicate there's no difference. This indicates that we have a significant decreased risk of hip fractures with increased aerobic exercise in older females. And you've got age ranges down here. So although I'm not really sure why this study made it in, that really shouldn't be included in this. And note that it was one of the only ones that actually crossed that threshold, meaning that it was not significant. So anyway, interesting. Okay, we already went over cognitive function, so this really ought to be in that lecture. So I'm gonna skip it. Sorry about that. This is a really great study. If you're interested in looking at the effects of physical activity on aging and the aging process, I really like this figure. I really liked this paper, so I thought I'd include it. But physical activity affects a variety of things. So it may affect chronic disease risk in general, right? Which we see increased risk as we age. But physical activity can help combat that. We see changes in functional status as you age. So especially thinking about ADLs and IADLs that we talked about in class last week, changes in psychological well-being, right? Especially if we can engage in, let's say, some type of group exercise or dance exercise, right? There's usually a lot more social components, and then social outcomes specifically. So community involvement, social network, social supports. So I just think it's helpful to consider that physical activity, yes, we can focus on its effect on chronic disease, but think about other ways in which physical activity may improve health as well. And then last thing, you'll cover this more in the aging and exercise class, or there's a new class that we're going to be teaching called Health in Special Populations, and they'll cover more about Alzheimer's there. But I just wanted to really briefly look at populational attributable risk. So could we decrease Alzheimer's disease with changes in people's lifestyle behaviors? So we have a couple of different things down here, but if we decreased incidence of diabetes by 10%, that's the number of Alzheimer's cases that would be prevented. If we decreased it by 25%, that's the number of Alzheimer's cases that would be reduced. And then you see lots of different stuff. So hypertension down here, obesity, depression, physical inactivity. So, and that's obviously the one I'm going to focus on. So it appears that there's some pretty strong associations between preventing Alzheimer's disease and reducing physical inactivity. So really, we're getting more at sedentary behavior here than we are at actual physical activity. But if we can reduce physical inactivity by 10%, we could drop the number of Alzheimer's cases diagnosed in the US by 100,000. And if we reduced it by 25%, reduced physical inactivity by 25%, we could reduce it by over 250,000 every year. So that's what this data is suggesting, which is pretty wild. So some of those cognitive diseases, decreases in cognitive function can be addressed by changes in lifestyle behaviors. You see smoking's down here as well. Cognitive inactivity could be paired with some increases in physical activity. Depression, we talked about last week, and how physical activity can affect that, right? So physical activity can affect most of these other risk factors. So it's sort of a big deal. Also, this figure is amazing. And so I included the reference for this article in the slide notes if you want to go take a look at it. Okay. Sorry, this will be 3 minutes or less. First, I wanted to come back to how to read research. If you're really struggling, one, you can always look for a summary. You can copy and paste some of this into AI and say, hey, can you give me a summary of this paragraph? Because it's a paragraph you're particularly struggling with. But generally speaking, with research articles, I'm going to start with the abstract. If I can really understand the abstract well, then I've got a good idea of what the paper is going to address. Not all of it, but I've got a good idea of the general picture. So my go-to, if I'm trying to understand a research article, is first the abstract and then immediately go to any figures that they have. If I can understand the figures in the abstract, okay, I've got a good idea of what's happening. And then I might go into the introduction because now I have a background on what I'm about to read about, right? The last paragraph of the introduction should be sort of what's the purpose of this paper. The last usually sentence or two of the abstract also has it, but if it doesn't, last paragraph of the introduction. First paragraph of the discussion is usually sort of major findings for any research paper. So those would be some key areas that if you didn't have time to read the whole paper, those would be some key areas that I would look at. Abstract, figures, last paragraph of the introduction, and first paragraph of the discussion. Those would be like my big, okay, go to these to help you understand what this research is getting at. Okay, and then this specific article talks, the one that I want you to focus mostly on, that Straight article, it talks about multi-level modeling. All this means is that when we do repeated measures of people, the chances are that those measures are going to be closer to each other than to different individual measures. So this takes into account the fact that we measured multiple times, or that people in one specific geographic area might be more similar to each other than in another geographic area. So it takes into account this clustering or nesting effect that can happen with data that sort of messes with it a little bit. Random effects modeling we've covered before, but I just wanted to readdress it because it comes up here. From random effects modeling, what we get are hedges G and D. Hedges G is all it is it's an average of one population minus an average of another population divided by the variance in that population. Hedges D takes into account a little bit more of small sample size effects and weighted means effects. So small sample sizes, right, we can see extreme results in small sample sizes. The bigger my sample size, the less likely I am to see an extreme result. And if I have a really extreme result in one study, let's say, because it had a small sample size, that could significantly affect my average in a meta-analysis. Okay, so Hedges D takes that into account and says, okay, this was a small study and it had really big variability. So the confidence interval is really big. I'm going to take that into account and maybe weight my data in that study a little bit differently than in the other studies that had more participants. Okay. Multiple regression we've already covered, but that's just the idea that there are multiple variables that can impact my outcome. Okay, so in this study, power was the outcome variable. Okay, so I'm trying to predict power, and there's lots of different variables like age and sex and training status that may affect power. Okay. The main thing that they wanted to look at was does the type of training that I engage in affect power? Okay, so that's my main relationship. But they looked at several moderators of that relationship. And we talked about that in class again on Thursday. So hopefully you remember what a moderator is. Remember, we have this relationship. So training and power. Training is associated with power, right? But we may have this pathway. So training might be associated with power because of what? The training intensity, maybe the training type that I engage in, maybe the age of the individuals engaging in the training, the sex of the individuals engaging in the training. So we have all these potential moderator variables that affect that, or maybe the reason that we see the relationship between the training and the power. Okay, so they examine those as well. Okay, sorry that was long. I hope that you enjoyed the articles this week, and I will see you in class on Thursday.